Welcome to an introduction to integers. The goals of this video are to define the set of integers, compare integers using inequality symbols, define the absolute value of an integer, and then determine the opposite of an integer. Integers are the numbers that belong to the following set. You can think of this set as whole numbers combined with the non-zero negative whole numbers. Remember, the whole numbers are 0, 1, 2, 3, 4, and so on. So if we include the negative of the non-zero whole numbers, we would include -1, -2, -3, -4, and so on, and this is the set of integers. So if you're wondering why we should talk about negative whole numbers, there are a lot of real-life applications for negative numbers. For example, have you ever overdrawn your checking account? For example, if your balance is $50 and you write a check for $70, you would be overdrawn by $20. So it's better to represent that amount as -$20 because that's money that you owe. Or what about when you get your credit card statement in the mail? It's not listed as a negative number, but it really should be because if you have a credit card balance of $350, you really owe that money, so it would be better represented by a -$350 that you owe. Or if you watch a football game and a football team loses 4 yards on a play, you could use -4 yards to represent the result of that play. Let's talk about comparing integers. We can compare integers using inequality notation. We read inequality statements from left to right just as we read a sentence. We would read this: A is less than B. And if the inequality symbol is reversed, we would have A is greater than B. Remember, if you think of this as an alligator mouth, the alligator likes to eat the larger number. So when trying to compare integers, it's often helpful to plot them on the number line because the larger numbers are always to the right and the smaller numbers are always to the left. So for example, if we want to compare, let's say, 5 to -3, well, here's +5 and here's -3. 5 is greater than -3 because 5 is to the right of -3. Remember, this is equivalent to saying -3 is less than 5. Notice how the inequality points to the -3 in both cases, or it opens toward the 5 in both cases. Let's take a look at a few more examples of these. We want to compare the following integers using less than or greater than. So let's go ahead and plot these two on the number line. We have -3 is here, +4 is here. So we know that since -3 is to the left of +4, -3 is less than +4. For the next example, we want to compare -3 and -6. Here's -3, here's -6. We're starting here with -3. -3 is to the right of -6, therefore -3 is greater than -6. Now let's talk about absolute value. The absolute value of a number is a number's distance from 0. And distance is always positive. If you get in your car and drive from home to school, or from school to home, in both cases the distance is positive. So you can think of it that way as well. And we use a vertical bar to represent absolute value. So here we want to determine the absolute value of +5. Well, +5 is 5 units from 0, so this is equal to +5. Well, the absolute value of -5, here's -5, well, the distance from -5 to 0 is also 5 units. So these two numbers have the same absolute value. And again, notice that the absolute value of positive and negative integers will always be positive. Let's go ahead and do a couple more comparisons using less than, greater than, or equal. To do this, I recommend evaluating the absolute value first. The absolute value of -5 is 5 because -5 is 5 units from 0. So we're really comparing +5 and +4. Well, of course we know that 5 is greater than 4, so we use the same inequality to compare the absolute value of -5 and +4. For the second example, the absolute value of -3 would be 3. The absolute value of -6 would be 6. We know that 3 is less than 6, so we use the same inequality to compare these two absolute values. Now let's talk about one more topic. Opposites are two numbers that have the same distance from 0. So the opposite of positive 4, what other number would be the same distance from 0? Well, that would be negative 4. They're both 4 units from 0. The opposite of positive 7 would of course then be negative 7. So now when we're asked to find the opposite of negative 5, we can see from the number line it's going to be positive 5. One thing I want to point out here is for the first two examples we just took the opposite or negative of the given number. So we could say the opposite of negative 5 is the negative or opposite of negative 5, which gives us positive 5. Now that's a little bit confusing, but again you can think of it as the opposite of negative 5 is equal to positive 5. And that's important to recognize because sometimes when working through problems we will encounter a double negative or the opposite of a negative. In the last example, the opposite of negative 2, of course, would be positive 2. But again, just reviewing this notation here, we could write it as the opposite of negative 2 is equal to positive 2. But if you're thinking, why can't I just change the sign to determine the opposite of a given integer? And you can, as we see here. But again, we will see this notation here occasionally, so it's important to recognize that this would be positive 5 and this would be positive 2. We'll go ahead and stop here for this intro video. I hope you found this helpful.